Okay, so hello. I'm just going to very quickly go over some of the very basics of circular functions, okay? Now, this is probably, based on what you're going through, I'd say this is probably still, this is definitely for me the hardest topic we've done. And I'm just going to go through the first chapter, some of the real basics. So, what we'll do first is we'll go from degrees to radians, right? And remember, radians is that special thing we use in the unit circle, and that's kind of an important measurement, right? So let's say we're going from 60 degrees, and we want to go to radians, right? Like that. What we do is we take this, and we times it by pi over 180. Now, the way I remember this is that I know to go from degrees to radians, it's going to be less, right? Because I know radians are kind of generally smaller. So what I'll do is I remember pi on 180 is smaller. That's kind of how I remember to use pi over 180 instead of 180 over pi, okay? So when we do that, what we'll end up getting is 60 pi over 180. Now we can cancel this down a bit. These go. 6 goes into 18 three times. So what we end up getting is pi over 3. Now, there's a special radian sign, that little C I just drew. You don't really have to include it. Normally if there's a pi in these measurements, you can kind of just forget it. But that's basically how to go from degrees to radians. So I'll do one more. Let's take 144 degrees to radians. Okay, same thing. If we multiply this by that, what we'll end up getting is 144 pi over 180. Now this is a bit hard to work out. What I did first is I halved it, which gives us 72 over 90. Don't forget the pi on there. So hopefully what you can see here is that this and this are both multiples of 9, right? 8 times 72. 8 times 9, sorry, makes 72, and 10 times 9 makes 90. So what we get is 8 over 10 pi, and that quite nicely goes to 4 on 5 pi. Add a little radian sign. So that's how to go from degrees to radians. Now, I'm just going to erase all this, and we'll go the other way. We'll take it from degrees, or radians either, and we'll go to degrees. Now, you can probably already guess how you go, so I'll just show you one of these. After that, we'll do some basic stuff with the unit circle. Right. So, degrees to radians. And now, radians to degrees. So, let's take something a bit simple. 2 pi on 3 radians. Now, instead of timesing by pi on a half, we times by pi on 180, we times by 180 on pi. So, we take this to 2 pi over 3 times 180 over pi. Now, the reason I remember the pi on the bottom is because I know these two are going to have to cancel out at some point. So if we take that further down, oops, bit of yellow again. If we take this further down, what we're going to get is 2 times 180 over 3. So 2 times 180 is 360 over 3. Now, if we just forget about the 0 on the end, 3 goes into 36 12 times, add the 0 back in, you get 120. Bang. Easy and simple. Now, after this, we'll quickly go on to the unit circle. So let me just erase this stuff. And there we go. Right, So now we all remember the unit circle, this dreaded monstrosity here, but at least for the first bit, it's kind of simple. Now, I'm not going to go into which side's tan and cos, I just want to show you where to find radians on the unit circle, right? Now, what I was thinking about it, one revolution, all the way around, that's going to be 2 pi radians, right? Now, half of that is pi. Half of that is pi on 2. Now, this is a bit different, but we can kind of see that's pi on 2. That's the same as 2 pi on 2, and that's going to be 3 pi on 2. So using this, if we got something like, oh, I don't know, pi on 3, it should also be noted this is also 0. If we got something on pi on 3, it's less than this, right, but it's bigger than 0. So pi on 3 is probably going to be somewhere like here. But the main thing we need to know is just what quadrant it's in. And we know that's in the first. Now if we took something else, like 5 pi on 6. Now that's a bit difficult. But we know that 5 pi on 6, well, that's kind of similar to 6 pi on 6. Which is just pi. Bang. But it's less than that. And we know it's going to be greater than a half, because otherwise it'd be 3 pi on 6. So no, this is probably going to go somewhere here. And we know now that's in quadrant 2. This stuff, I'm sure you probably know this, but it's quite simple. So I'll leave that there for now. Thank you.